Okay,
I don't
so
think.
today our topic is dynamic programming and the max subset some no adjacent. So obviously we're gonna trying to find the subset maximum and that is without adjacent numbers. So the prompt is write a function that takes in an array of positive integers and returns the maximum sum of the non-adjacent elements in the array. If the input array is empty, the function should return 0. So sample input array is 75, 105, 120, 75, 90, 135. Then the sample output is 330. Okay, so I don't know, like I got a sample which is different from that sample, but I guess that's fine. So I'm gonna change our sample output, input and output for a little bit. Okay, but it will
Hold
still.
on. How did they get 330? So it says array of positive integers that are not adjacent. So 75 is not adjacent to 120, but why did it jump to 135? Isn't 90 not adjacent to 120?
Okay, so
We
I
want to
got.
maximize the
Oh,
maximum
oh,
sum.
oh, oh,
See?
oh, 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 okay.
So that's yes. Okay, so I'm gonna delete that one. Okay, cause I think I did. That's fine. Yeah. Sorry, that will be 33. So 33 will be 7 plus 12 plus. So we just use different example, but it's the same thing. Okay. So the given input array is 7, 10, 12, 7, 9, 14. So we use that one just for the math. It's easier to add up. Okay, so we're gonna so does anybody has any clue about how to solve this problem? Like, do you guys understand the prompt? Or can you please not highlighting because nobody can see the number? Cabana, can you move your cursor to next line, please? Yeah.
Yes, yes.
Okay. Okay. So, does anybody understand the question? What we are going to do and what is the goal and what is the maximum sum of non-adjacent elements in the array? Um,
I think you should ask those who don't understand it. First.
yeah,
So
that's
first thing is, let me. I was just trying to read it out loud to myself. Is first thing is,
yeah,
it's looking for the number. You look for the max number and make sure that it is not adjacent to
yes,
the next max number. Is that the right understanding?
No, you want to get the three numbers in your array that will maximize the sum when you add them all together. That's
Why only
plain-
three?
That's just whatever. I mean, not three. No, any number elements that give you the maximum sum possible. So if you had 10 whatever elements, it could be 6, it could be 4, 3, I don't know, whatever. But it depends on the numbers that are in the array. So all you care about is getting the absolute maximum number when you add them together, whatever combination of elements, as long as the elements are not next to each other.
Would it be okay to like deduce from the question is that you take the length of the array and divide it. Those are the maximum numbers that you would have to sum together, and then you decide whether they're adjacent to each other or not. Is that the right?
No.
Can you conclude?
No.
No?
Not really. I mean,
It's-
I guess you can
On
get the
average,
maximum number.
it can work, but
Yeah.
it's not consistent to do it that way because you don't know
Because
how
you can
many
have-
the size of the numbers inside.
Yeah, you can have 0, 0, 0, 0 repeating a million times, right? And then have just 1, 2, and 3 somewhere. So you only need 3 numbers out of a million that give you the maximum numbers if everything else is 0, right? So it's all dependent on the actual values of each element in the array. Does that make sense?
Okay, so I just gonna walk through the problem. Okay.
I mean, I just want to to make sure we understand it. So, yeah, we just want to make sure the find the largest sum of numbers not next to each other. So basically, just taking a group and then taking another group and then comparing, see which sum is higher, and that determines which group we use, and then we kind of do the same thing over and over again until we go through the entire array, and then Jen will hopefully explain, how we determine the groups and how we determine which one is bigger than the other.
Yeah.
Yeah.
Okay, so let's just walk through that one and see the manual. So we do manual first, then we do automation. Okay, so we're gonna do manual, walk through, so basically you ask us to return a maximum sum of the non-adjacent elements in the array. So our given input array is like this. It has 1, 2, 3, 4, 5, 6 elements, right? So how can we get the maximum sum? We're gonna get I would say thought process will be step 1. Calculate the subsum first. Then we subsum of non-adjacent element. Then we compare each subsum and choose the maximum value. Do you guys agree with that thought process?
Repeat that again.
Okay, I'm gonna write it down on line 21. Can you see it, June? Line 21. Okay,
Yes.
so calculate the subsum. Sorry. Subsum or sum sub, whatever, subsum of the non-adjacent elements in the array, right? Then step 2, then we compare each subsum and choose the maximum sum value.
Right, okay.
Yeah. Each subsum, and step 3, choose the maximum value. Okay. So that is the general process. Choose or return the maximum value of the subsum. Okay, so let's just walk through manually. So this is our input array, right? So when we
You'll need another array. Won't you need an array sum, an array called array sum?
we don't do variable for now. Let's just demo the walkthrough, what we
Okay.
do, like always. Okay, so demo or walkthrough. Okay, so when I equals 0, what will be the subsum?
7.
Yes, 7, right? Then when I will say round 1, then let's do like this as traditional round 2. So when I equal to 1, so that will be, then we have 2 elements, right? So it will be array at index 0, which is 7, and the array at index 1, which is 10.
Right.
But we can only choose 1. Do you know we cannot add them up because it says the maximum sum of non-adjacent elements.
Right.
So 7 and 10 is adjacent element. So if it's non-adjacent element, it will be 7 plus 12. That will be the first qualified subsum, right? You
Right.
understand?
Yeah.
Yeah. So if that's the case, we just choose the maximum value, right? Because we cannot add them up. We cannot add the 7 and the 10 because they are adjacent elements. We choose the max value as the subsum.
But if we are handling any array which has only 2 elements and length of it is 2, then we can return any max of both elements.
So if I
Right.
gave you an array of 1 and 1.2, what would be the max sum?
1.2, right?
Yeah.
So that will be, so for first one is 1, second one is 1.2, like 1.2 plus 0 because we cannot add its adjacent.
No, what I mean to say that if the array is only, its size is only 2 elements, then we have to pick the max sum. So then we just pick the element which has max value, like either 0th element or the first element. So, but we compare those 2 elements and return the max.
Yes.
Can you guys answer,
Yes,
please?
exactly.
Yeah. So what it's saying is right. Which is what you're saying.
Just remember the constraint that the numbers cannot be adjacent.
Adjacent,
So whatever your solution is, every element in that array cannot be adjacent to any other one.
Yeah, correct.
So do you guys agree that when I equals 2, which is, so our element will be 7, 10, and 12, right? Then subsum will be what? 7 plus 12. And is any alternative subsum when I equal to 2? So like 7 cannot add 10, 10 cannot add 12 because they are adjacent. So for the sum of non-adjacent elements, for these 3 elements, the only possible way is 7 plus 12. Do you guys agree, or do you have different opinion for that, for round 3?
No,
That's
agree.
correct.
Do you guys agree? So
Yep.
do you guys agree for round 3, the maximum subsum will be 19? Do you guys agree?
Agree.
Okay. So should we move on now?
Yeah.
Okay. So round 4, right? When I equals 3. Okay, when I equal to 3, let's do 0, and that will be
And
7.
then 19.
0, 1, it will be 10. So, like some problem very difficult, but once we break into small pieces, like step by step, it will be clear, That will be 7, right? The second 7, I put the second 7. And the first 7. Okay, so, can you guys tell me what is the subsum for round 4?
17.
Okay, we don't do the maximum yet. We do, like, what's the possibilities for the subsum for round 4? Do you want to try?
Yeah, 17 and 19, right?
Okay, can you tell me what plus what?
10 plus array 1 plus array 3.
So 10 plus 7, right?
7
Okay,
is
I
1.
okay. Maybe I just write that array 1 plus array.
Array 3.
Yeah, that is more clear. So that will be 10 plus
7.
second 7, right?
Second 7, yeah.
Yeah. So that will be 17, right?
19.
And
And also array 0 plus array 2
yes, array 0
plus
plus
array 2.
array 2. So that will be first
7 7 plus 7 plus 12.
Yes, so that will be 19, right?
Right.
Okay, so now it says we want the maximum subsum. Max subsum will be that clearly?
19.
19.
Yeah, so choose 19, right? Choose the maximum value of subsum. So that will be 19. Okay. Okay, so we're gonna move to round 5 now. Round 5 when I equals to 4. Okay. So I can copy that one first. Okay, then array at 4, that will be 9, right? Okay, so okay, let's say some possibilities. Some possibilities. Okay, I'm gonna pick Habana, you wanna try the possibilities of subsum?
Yeah.
Okay, what
So
are
we are
possibilities? Subsum of non-adjacent elements.
So we are at value 9, right?
Yes, we are the fifth iteration.
Yes, line 70.
So will you copy all those from top, from round? Okay, you have.
You tell me.
So now we add 19 plus 9 actually.
So array what?
19.
Array 0, right? Can you
Yes.
order?
Okay. Array 0 plus 1 second. Array 1, 2.
Array 0. Array 0, array 2, right? And
Yes.
do you want
array 4. Array 4.
Okay. Okay, so that will be first 7 plus 12 plus
12.
this how
9.
what is that? 19. Hold on.
28.
19 plus 9, 28, right? 28.
Yes. Yes.
Okay, what will be the second subsum?
Second subsum would be same, like it doesn't change because 9 is adjacent to that, so we don't count the fourth element. So there is no change in its subsum.
Will be 10 plus 7?
Yep.
Yeah, correct.
Yeah.
Array 1 plus array 3.
Yeah. Okay, array 1 is 10, array 3 is second 7, right?
Yes, 17.
That will be 17.
And then the last one would be array 2 plus array 4, right?
array 2 plus array 4. Yeah, I would say that. Okay, Darren and Ray, can you guys help check this? Because this is a little bit complicated. So how many values will be wrong size for the subsum? Okay, Joe, you say
Array 2 plus array 4.
Yeah, array 4. So 2
That's
is
12.
12.
12 plus
And
9.
4 is 9. So that will be 21, right?
Yep.
Yeah, 21. Yes, any more possibilities? 0, 7, 12, 9, and 10, 7,
That's it.
12, 9. I think that's
I
it.
think that's it. That's it. Yeah.
7, can you check for us?
What am I even checking? I'm not even sure what you're asking me to see if your code is correct. I mean, if you're.
Do you agree?
Also, she's asking you to check if there are any other possibilities or what from your point of view.
Yeah.
I see. Yeah, I wasn't looking at this. I was thinking of my own code. I was looking at the different examples. So I'm like, I don't know what I'm looking at right now. But as far as 7 and then 10, 7 plus 12, that makes sense. So 21 or 28, which is. Wait. 1, 3, 2, or 4. No, that's all the possibilities for that round.
Okay. So that will be, then we choose the maximum subsum, right? Choose the maximum subsum, which is 28.
Correct.
Ray, you had something you wanted to add?
Oh, I mean, I was coding too, so I wasn't really. If you're saying all the possible combinations,
Why
I
is
doubt
that
you have all the possible. I'm looking at your pattern. I see you're skipping by 2. So from that, I can tell you that's not all the combinations. Because you don't have to follow by 2. You can skip by 3. You can skip by 4. You can skip by 5. Just in the chat, I had zeros by every 5 or 6 or 10. So that doesn't take into account all combinations. But usually when you alternate, depending on the numbers, you might land on the 1. But that doesn't mean you have to skip every other one to have the maximum subset. It all depends on the values. So looking at what you guys did, I doubt you have all the combinations, but your likelihood, because it's a small number of elements, you probably have, you landed on it by chance, but I don't know without really looking at all the numbers.
Yeah, so because usually if you're in the coding interview, you have no idea how to solve it. You have no idea what dynamic programming is. Usually what the first thing they tell you is, well, how would you solve it on paper? You know, how would you solve it without code? Just in your head, how would you figure out, the maximum subset of things where the number's not adjacent? Well, if I had a sheet of paper and I was just scratch papering it out, in my head I would add, okay, 7 plus 12 is 19, and I'd put that down, and then 10 plus 7 is 17. Okay, that's good. You write those two numbers down. 19 is greater than 17, so I would keep that, and then you add 19 to the I don't have scratch paper, so this example is tough. I wish I had some right now. But you would, sketch that out, and then you would compare 19. Is 19 bigger than...
Our note-taking .md.
So going along Devin's path, if I'm looking at this, the first thing I do is I go left to right. I pick out the biggest numbers. Are they next to each other? No. 12 and 10 are next to each other, so I pick the bigger one. I pick 12. Since I can't use 10, I'm definitely using 7. So 7 and 10, 12 would be there. And then I look at 7, 9. 9 is bigger, but 14 is bigger. So I'm not going to pick 7 or 9. I'm going to pick 7, 12, and 14. That's my answer as a human, looking at this logically.
Yeah, but right now we are trying to do other possibilities. So our
Well, that's the
logic,
thing. If you're only skipping every other one, then you just missed the one I just did by looking at this. Me as a human looking at this, I just saw I can see 7, 12.
we are not on 14 yet.
That's
Our answer is 5.
we're
We are
not.
12, 7, 9 now.
Well, you asked
We
if
weren't
you got all
talking
the
about
combinations.
rounds right now. We're just talking about how would we solve it without code. If someone just asked you, like, you know, if someone asked you to guess the maximum subset at a carnival and you win a teddy bear or something and you win a prize, you didn't have to code it. Like, how would you solve it in your head? That's what you do. You try to see the biggest numbers possible. In Ray's case, we see 12 and 14 are the biggest. Then you see if they're next to each other, and you kind of try to add from there. And so once you figure out a decent enough strategy to solve it without code, you would try to implement that as best as possible with the code. So how would you solve it without? You kind of try to get the biggest sums you can based on you need the biggest numbers for the biggest sums. So, you see your 7 and 12, it's like, okay, that works better than 10 and 7 because 12 and 7 is better because one of them is bigger. And then now that you've got that number, okay, you see what's the biggest adjacent number. Well, we can't use that 7 anymore, so we choose between 9 and 14. 14 is bigger than the 9, and so we add that number to the sum instead of... And that's what he means by you can't just check which number is... You can't just check every other number. You have to check the biggest number out of all the numbers that aren't next to it.
Yeah. And there's a very systematic approach, right? That you're going to come up with the algorithm. It's going to be much more systematic than what I came up. To me, my intuition is to look at the biggest numbers and say they're adjacent. But there's a very systematic. You look at each one.
Right now, we are not doing dynamic approach yet. We're just trying to understand the problem, then pick the max sum because people don't understand what's going on for that question.
We know. That's kind of why we brought that up that way.
Yeah. Okay, so let's finish last round. Then we're gonna talking about dynamic programming. So right now it's not dynamic. Right now it's just like a thought process. How that question, like what is this question ask us to do? Okay.
Not everyone sees it the way I see it, right? The first thing I thought of, I look at the biggest numbers that are next to others. Not everyone thinks that way. They might think differently. They go left to right, And the way when we come with the algorithm, you're definitely going to go left to right and do it one step at a time.
Okay. So John, we continue. Okay, John, are you there?
I'm here.
Okay, let's do so round 6, I equals 5, right? So first possibility will be array at index 0 plus index
array 12 plus
4, that is 28.
Right.
Then the second will be array 1, array 3 and
array 5.
Yeah, array 5. So that will be array 5. It will be 14, right? So that will be 10 plus 7 plus 14, 17 plus 14, 21.
Right, and then the last one would be the same, array 2 plus array 4.
Array 2 plus array 4, yes. So that is 21, and we maybe have another combination, which is, we did a 0, 2, 4, 1.
We didn't do 2. Wait, what happened?
Okay, we didn't do 7, 12, 14. That one. The first one and the third one and this one. Oh, cause right now it's not addition, cause this is like 2. Like you skip 2 numbers.
Right.
So the combination will be more complicated than the previous, like we just did, because
Yeah.
now
I think that's what Ray was saying is
Yes.
once you do it by
Yeah.
skipping once, then you do it as it grows. You do skip twos, then you
Yes.
skip threes, and see what combinations come up with your maximum sum.
Yes. Okay, so that will be, let's just do whatever, then we will be choose the largest three
So
numbers.
yeah, so it'll be array 0 plus array 3
Uh-huh.
plus array 5.
Array
Array
0
zero.
plus array 2 and array
Yeah.
5.
Yeah.
Okay. I'm just gonna copy that one. Yeah, so thanks, Ray and Devin. You guys are right, 0 plus 2 plus 5, right? So that will be,
33.
that will be 7 plus
12 plus 14.
14. Yeah, so we got the answer. That is 33. So like we got like first is 28, second 31, third 21, then the fourth is the 33. So we choose 33. Okay, so that is how we got to 33. So conclusion. We are trying to build a new, build a array named subsum, subsums or whatever. So that will be all the value we picked. So for the first value, what will be our first value? That is 7. Do you guys agree?
Mm-hmm.
Okay, what will be the second value? So that will be the round 2 we picked. Round 2, we choose 10, right? Round 2, we choose 10, then we push in 10. Then round 3, what we choose? Round 3, we choose 19, right? 19. Okay. Then round 4, we choose
19.
Yeah, 19, right? Here, we choose 19. Okay, so last round, round 5. Not last round, like round 5.
No,
Round
that's
5,
not-
we choose.
second to last.
Round 5, we choose which one? Everybody?
33.
No, round 5.
No, round 5 is 21, right?
31.
No, 28.
28,
28.
sorry.
Yeah. Because the first one, 28, second, 17, third, 21. So we choose the largest one is 28. See, we write the conclusion here, 28, or summary. Okay?
Right.
Then we have last round, we choose
33.
Yes, 33. Okay, so then we got that one. Then so from above array,
Choose the max.
yeah, above rebuild array, name the subsum, okay? Name the subsum. We got maximum value for that. Find the maximum value. So that is 33. So that we got sample output, which is 33. Okay, so that is kind of like a demo. How so? What does maximum sum of non-adjacent element in array means? So before you guys like no clue, don't know how those numbers become 33, right? At least we demoed, you guys understand how these become 33 and the relationship. But the demo we did is not the optimized solution or formula because it's like manually. So if the array gets really large, then our method will not work because it's too many steps. So
Right.
that's why we have to find a formula to kind of like emulate the manual steps and make it a smarter way. So we use dynamic programming. So that is the dynamic programming come out. Okay, so now we're gonna talk about dynamic programming approach. Okay. Okay, so dynamic programming approach, yes. Hold on a second, let me take a look. So according to our manual walkthrough, do you guys have any idea how we're gonna implement the dynamic programming approach? It's more like Ray and Devon said.
What did
We
I
have to
say?
loop over the array.
Yeah, personally, I would think like either you start at index 0 or 1, and apparently you could choose the maximum value between the next four indices, and whatever value that you choose, you increment the current index by the index of the chosen value plus 1.
Yeah. So basically, we can see like we have two values are kind of like solid, which is like the adjacent numbers, right? Then we're gonna pick another value to add up, which is non-adjacent. So at least we can confirm two adjacent values. So yeah, I don't really know how to say that, but I just gonna write the formula for
the point. So dynamic programming is basically you apply it to recursions, right? Recursions aren't necessarily the most optimal, and you can get Stack Overflows because you could run out of memory. But the point is that the dynamic programming is caching or saving or reproducing, breaking down your subproblems and saving those subproblems to use later on. So you only have to compute them once, right?
Yeah.
So the classical Fibonacci series, those who've implemented many times will know, like the memoization way or the bottom-up approach, is you're basically caching a subproblem, so you only do it once. Once you have solve that subproblem, you're going to refer to that later in your cache. That's the whole idea. You're going to break this into subproblems. You're going to find your previous values. Maybe you took it index 0, maybe you took it index 5. Those 5, you save that value in your cache, and then you update that cache accordingly. Now that you know this is your maximum number, you solve maybe it's 10 at this point in time, right? Whatever the numbers are. I'm just making up some numbers. Okay, 10 is my maximum number at this point in time. I go to the next index. Is it higher? Oh, then I have to update my cache. I reuse that number 10 and compare it to my new number that I have to add to. Is that higher? Then I update my cache, my subproblem, right? That's the point of dynamic programming, is that you're reusing, breaking down your subproblems and caching that value to use later on.
Yeah.
Yes. So basically, we need to build that. We need to build that array, right? Then find out. Okay, so yeah, I just gonna write the formula. Okay, so here, a formula for that. Maybe I write the formula, then you guys help me, kind of like explain.
Define formula. What do you mean by formula?
So we have a formula to to do that, then it will be, we don't need, then it will include all the, like all those kind of problems using that formula. So it's a universal formula.
like an algebraic expression or something? Like that's all like
Yes,
Yeah.
yes.
No. So Jen, you're really going to be writing down is the pseudocode algorithm code.
So I am saying it's the index.
It's not really it's not an equation. It's going to be your pseudocode, your algorithm.
Okay, I was like, yo, I missed this part of math class where it's like
There will be
Okay,
a max
Okay, everybody, kindergarten lecture now. I'm just gonna give you the formula, then you guys put the numbers inside the formula and verify the formula works, then we're gonna move to the code. Okay? So, okay, the formula is here. Formula is maximum sum at index I, and we're gonna choose maximum value, and the maximum value can have two ways. So I just gonna put this one. The first way will be, first approach will be max sum at I minus 1, and so I put a comma. Comma means either choose first one or choose the second one. Okay. Maxing sum I minus 2 plus array at index I. Okay, so that is the formula. How we gonna find the maximum? So that is maximum is 33. Okay, maximum I is 33. Okay, let's implement the formula.
yeah, we could have saved this part for the code.
Yeah. Okay, let's implement the formula, everybody. Okay, so implement is just walk through the formula. So you guys can understand, and so the formula is the algorithm. If you guys understand the formula, you guys understand the algorithm. That is how it is, you know. Okay, so so we're gonna walk through the formula. So round 1, when I equal to 0, right? Okay, what will be our maximum sum? So that will be 0 equals max value. Okay, so first one will be max sum I, which is 0 minus 1, and second choice will be max sum I is 0 minus 2 plus I array I. Okay, let's increment the value. So that will be maximum sum will be, so that will be 7, right? So that will be maximum value. Okay, so that will be first choice maximum sum I minus 1. Okay, hold on a second. Oh, sorry, this formula is start from start I equal to start.
So what is that 1 dot z, 2 dot z?
Because when I equals to
She's
0,
just indicating it as a differentiator, Kalpana, like an A, B.
Okay.
do you guys understand? So when I equals 0, it's just first value and second value, then you just choose which one bigger. So we don't have the issue about June. Remember, the only issue we have is it becomes bigger and bigger, then you don't know skip one element or two elements or three elements or unlimited element, right? So
Right.
so if we only have two elements, we don't have this problem, you know. So that will be our base case or edge case. So we'll say edge case. You guys understand? If don't understand, make sure understand. Edge case one, I equals 0. So it will be first element and the second element. Okay, when I equals 0 and when I equals 1. So that's why our problem starting at more than 3. If we have 3, then we have problem. So that's why we're gonna do this magic formula to when I equals 2. Start at I equals 2. So we have at least 3 elements. Okay? Do you guys got it?
Yep.
Yeah. So it would be more clear if you say like array length is only 1, then the max sum will be the first element, and if its length is 2, then we consider both first and second and take the max, and then we start with I equal to 2. The index is 2.
Yes, that is the pseudocode. Cabana, do you have access? Can you write that one in line 172 so I can implement formula? Because yours is pseudocode for base case. Let's collaborate. You write whatever you just said in line 172.
Okay.
Yeah, I'm gonna write this one. Okay. So when I equals 2, right? So max sum. Hold on a second. That will be what is my here formula? Okay, everybody, formula is on line 154. Okay, that is the formula. Everybody, 154 is the formula. So when I equals 2, so max sum is 2. Max value first one is 0 minus or not 0, 2 minus 1. Then that will be 2 minus 2. Then array at index I. Okay. So let's implement the numbers. So first, maximum sum 2 minus 1 maximum sum, that will be 10, right? Do you guys agree?
Where is the array? Can we look at the array? Can you copy the array down so we?
Array here. Array on the left. Everybody here. Line 12.
Oh, okay. I was looking at the.
Oh, I'm gonna copy the formula here. So if you guys forgot, you can see the formula. Okay, formula right here. Formula.
All right. So Jennifer, take a step back. Did you explain what that formula means at a high level?
So let me get the number first, then you explain the formula, okay?
Oh, I
So
don't know if
once
that's
we
good.
got the number come out, you guys understand. When the numbers come out, you guys understand, okay? So let's say the first choice, max sum 2 minus 1, which is 2 minus 1, which is 1, so that the value is 10, right? Then the second option is, remember the comma means up means all, okay? So that means all. Okay, so the second one is what? Maxim, that was the max sum 0, that was 7 plus I equals 2, that is 12, right? So that will be 19. So if it's correct, then we're gonna choose the next one. Choose the large one. So that's why we choose 2. So that is 19. You guys got it?
Yeah, I feel like we need to
think
get
so.
to the code now.
That is the same way. When we do manual code, it's the same. So we will verify the formula. That's correct. Okay, then we're gonna do I equals 3. Okay. Okay, I'm gonna ask someone implement the formula so you guys understand the formula. Okay. Choose June.
When I equals 3, max sum 3
Okay, 3. Okay, max
equals
sum is 3, right?
3
So,
equals max value. Max sum 3 minus 1
max. Hold on. Max sum. Yes.
sums 3 minus 1, comma. Max sums 3 minus 2 plus
3 minus 2 plus array at 3,
at
right?
max sum 3, yeah.
Plus I is 3, yes. Okay, so what will be the max sum 3?
So it will be max value of 3 minus 1 is 2. Max sum 2 is 12.
So first, this is what max 2. That will be 0, 1, 12, right? Okay.
12. And max sum 3 minus 2 would be 1. That is 10. 10 minus
10 plus 12.
10 plus 12, yeah.
Oh, no, 10 plus 7, right?
10 plus 7, yes.
Index 3 is 0, 1, 2, 7.
Yeah.
Yeah.
10 plus 7.
Yeah. Okay, so that will be equal. Then you choose which one. Yeah.
So now we choose the max sum, which is
17, right?
17, yeah.
Okay. Yeah, okay, I'm gonna write this one. So this is max sums at index 2, which is 19. No, actually we should get to the. So remember we have something like this one we are trying to build. I'm gonna write right here. We are trying to build that one. So we start from index at 2. So that was 7, 10. We don't need to do that because it's edge case. Then we have 19. So that will be max sum at 2, 0, 1 to 19. We got 19, right? Then that one should be 19 too. 0, 1, 2, 3, it should be 19.
Yes,
Let's
it should
see,
have it.
yeah, let's see where we got wrong.
It's what numbers are you even comparing? It's supposed to be I is supposed to be equal to 12, and we're supposed to compare if I minus 1 is equal to I plus I minus 2. So we're supposed to be seeing if 10 is bigger than 7 plus 12, not whether 10 is bigger than 10 plus 7.
So for the first one, yes, max sum at index 2, which is 0, 1 to its 12, right? Do you agree this?
Actually, here we are not taking the value exactly at the index. We are verifying because I minus, like 3 minus 1 is 2. 2 in the sense, okay, it is 10.
So this is index 3. Okay, so we're at index 3. Index 3 is 7.
1.
0, 0,
Yeah,
1,
index 3 is 7.
3, yeah, 7. That is 7.
We're supposed to be seeing if 10 plus 7 is greater than what should be 19. So we're supposed to be comparing if 17 is greater than 19, which it would not be.
Oh, you mean this one compared to the previous one?
Yes.
Actually,
Okay,
maximum,
right.
yeah.
We're
Maximum
we're
is
keeping track
19.
of the largest sum in place. So whatever index we're on, by the end of that loop, that index will have the largest sum to date.
Yes, you are so smart. So keep a track of what? Can you write that sentence, Devin? Keep a track of the running max sum, right? Then we
Keep track of the
compare.
max sum in place.
Then we choose the maximum value. Yeah, that's right. That's why I don't fully understand. So here, okay, here. Do you got it? You?
So we're not building an array. We are just
So
at a given point. Is that Devin? Is that what you're saying? That at a given point, it'll always be the max value as of that in place as of that position.
So
Yeah,
if for the loop, I is going to be our current number in the array. I is going to be our current number in the array. I
Right.
minus 1 is always going to be the biggest sum that we have so far. By the end of our loop, we're going to replace our value of I with either the new biggest sum or the previous biggest sum, depending on our formula, our mini algorithm, our equation here. That determines what our value of I will be at the end of the loop. So we're comparing our current subset. We're comparing our current max sum no adjacent, which is our I, plus the value of I minus 2, so 2 indexes ago. And then I minus 1 should have whatever our previous max sum was. And if it's bigger, then we replace it with that. It's hard to say verbally. But we basically are comparing two sets of sums. We're comparing current I plus I minus 2, and we're comparing that to I minus 1 plus I minus 3, kind of. And we're just comparing the two subsets, and depending on what's bigger, that's what we use. It's not the best verbal explanation, but
So you're not using an array in any shape or form. You're using basically 4 variables, and you're
we're
keeping track
mutating
of.
our existing array, basically. That's what I mean by in place. As we loop through the array, we don't necessarily need to keep track of the previous array numbers, because we incorporate them in our sum. As we keep going through our array, the indexes will keep track of our largest sum up to that point. So if we're at right now max sum index of 3, right? So max sum's index of 3 will store the largest sum based on the values of indexes 0 through 2, whatever the largest subset is of non-adjacent numbers. And then by max sum's index of 5, it will carry the max sum of indexes 1 through 4 as far as values that are not adjacent to each other. So the further along we go in the array, each index will store the max sum of the indexes that came before it. If that makes a bit more sense.
Yeah, that kind of makes sense. It's still a little hazy, but yeah.
Yeah, it's still a little hazy, but yeah, basically, yeah. So basically, the further we go along in the array, our values will just store the largest sums before it.
What threw me off? What threw me off is when Ray said, "Oh, you guys are skipping, so So the way I understood is if we had 7, 10, 19, 19, 28, 33, 54, 56, then the combinations. So from the first pass you go one skip, one skip, one skip. Then the second pass you go 1, 2 skips, third element. Then the third pass you go 1, 3 skips. Then you pick up the fourth element. Isn't that not the way?
I never said skipping as a pattern. I said my logic is I looked at the largest numbers first. As long as they're not adjacent, then I just did it through my mind. I could see this looking at it, but I never said a particular pattern. I gave you patterns in the chat. I put 5 and 10 zeros between the ones. So there's no pattern. You just have to take into account you have to, after each step, you have to always record the maximum sum at that point in time based on your previous values, right? And then it will dictate whether if you, by adding the current index that you're on, the value, is that higher than the previous value, then update it. If not, then the best way is to take the previous two, right? Because you have to skip. You can't have them next to each other. You take, the current value, meaning added to, the previous one, two places before that, right? Because you can't have two next to each other. Is that value bigger than the previous one, which was the previous element that you recorded?
Okay,
Yeah.
so
Basically, it's not a matter of, is the even set bigger or is the odd set bigger? It's not what we're comparing. We're just comparing the largest possible numbers we can add, no matter how far apart they are, as long as they're not next to each other.
Gotcha.
Okay, so June, I find another way to explain better. Because in the previous we missed one step to update the one called the max sum in place. So we did not update the max sum in place. That's why. So we remember in the round 2, we calculate the max sums at round 2, which is max sums at index 3, right? The value is 17, right? Mm-hmm. So the first choice is 10, second choice is 17. First choice is 12, second choice is 17. Then we pick 17 because 17 is bigger than 12.
Right.
That's correct. But we forgot to. So that is, for that one is when I equals 1, max sum at index 3 is equal to 17. But in the previous max sums at index 2, which is 19. So we have to update max sum is 19. You understand? So we have the max sum at index 3, which is 17. Then we compare that one with the previous one to choose our current max sum. So we choose the bigger one is 19. Is index at 2 bigger than index at 3? We're gonna choose the bigger one. So we missed one step, which is that step. So I'm gonna write down that step, then we are good. So we're gonna extra step, okay, or bonus step, whatever step. So that is Devon talking about keep checking the max sums in place. So we did not do that one, okay. So we have to get one called the current update current max sum. Now it's right.
And if you, at each round, if you add, if you update the maxims array with its values at each index, it would be more easy to subtract and compare, Jennifer.
Yeah. Okay. So let's say in the round round 1, right? Our max sum is index I, which is 2, right? So that is do you guys understand?
Mm.
When round 1 I is 2, our max sum is index 2, which is 19, right? Which is 19 right here.
Right.
our round, okay, round 2, I is equal to 3. Our max sum is what? 17. Remember? When we're at I equals 3, June calculated it is 17, right?
Yeah, yeah.
Okay, so we got that step down, so that is 17. Then we're gonna implement the extra step,
Comparing the sums.
which is compare, update the current max sum. So that will be, so current max sum I, so it will be, is that one bigger or that one bigger, so we choose the bigger one. So that's why max sum in round 2 is 19.
Gotcha.
Okay, I think, Yao Yuli, do you understand?
Yes, I understand that.
Okay, do you want to explain this? Like, or
You start from
yeah,
the index 2, right? You just
Yeah.
check the max sum every time.
yeah,
Start from the index 2 because the index 2 you got the max sum is 19, and then later
Yes.
for the index 3 you check the max sum is 17, but the 17 is smaller than 19, so the max sum become 19, right?
yes, so that's
All right.
correct. Okay. Do you understand, John?
Yes.
Okay, so we can move on we have 2 more rounds, then we're done. Okay, so now we can do the same thing. Okay, so for the same thing, we're gonna do, let's say, so now do you guys remember, right? So the max sum at index 3 is 19. So we're gonna do that. We're gonna same formula. Okay. So that is max sum at index 4, right? So option 1 is max sum I is 4. I is 4 minus 2. Then array is equals
4.
Yeah, so let's calculate. Okay, so max sum at index 4,
4
which is equal to
max of
max
19.
Yeah. Okay, next value. First one is, First one is max sum at index 3 is,
Which is 19.
okay, so that is here, 0, 1, 2. No. Give input. This is root. This is,
Oh, sorry. 0, 1, 2,
No.
3. Okay.
yeah. So max sum at index 3, 0, 1, 2, 3, which is 7, right?
7, yes.
Okay, then the choice 2 max sum is
12.
2.
12 plus
0, 1, 2, 12, right?
Plus 9.
Plus 0, 1, 2, 3, 4, which is 9. So that is 0, 1, 2, 12 plus 9. That
Yes.
is 21.
21.
Yeah. Okay, hold on. Let me take a look. How come that is not? Um. Okay, so let me take a look. Current sum. 21. That's not right. You're supposed to 28.
So actually, max sums at index 3 is 19, right? What Joe said is correct, Jennifer.
Oh, yeah. Because we updated. Right.
Right, exactly.
Okay, so that is not 0, 1, 2, 3, 7 anymore because we are updated, right? So that is 19, right? Okay, so then thanks, it's good catch. So then max sum at index 2. So so now we are looking at here, not here anymore. So Joe, you are right. So we are looking at the current updated value, not the given input value anymore.
Right, exactly.
Okay, sorry guys. So max sum at index 2 is 0, 1, 2 is 19, right? 19 plus 9, now it's right, 28. Okay, so got it. Calculate the updated value.
Maximum, yeah.
Yeah. Yes, thanks everybody. Yes, we don't understand, we help each other, you know.
So max sum 4 at index 4 is 28, right?
Yes. Now we're gonna, yes, so now we choose, we're gonna, this one still just do it here. So we implement extra things. 28 is bigger than 19.
19.
Then
Yeah.
we choose that one becomes 28.
28. Yep.
Yeah. Now it's crystal clear. Even dynamic programming, we can be crystal clear, you know. Okay, so let's do round 4. That was the last one. Okay. Okay, that will be I equals 5.
Yep.
0, 1, 2. But when we iterate, we still iterate that array.
Yeah, exactly.
Because we have running sum, we write here. But
right.
When we iterate the given input array. Okay, so
right.
Yeah. Okay, so our so I equals 5, right? So 5.
Yep.
Hello, Fanny. Good to see you. So, Joe, after we go through the last round, you explain all the algorithm to Fanny summary. So make sure you understand, okay?
Okay.
Let's continue. Oh, you're gonna explain to Ray because he always for the summary only. Okay, he only care about summary, skip the process. Okay, let's do it, Joe. Okay, max value.
Max sum 4 minus 5 minus 1.
1. Okay, so that was 5
minus 2.
Minus 5. Okay,
and
so
5. So max sum
5. That will be
max sum 4 is 28.
Yes, 0, 1, 2, 3, 4, 28. Because we are doing the upgraded one. The upgraded one. Okay, so
max sum 2.
No, here is not 2. This is 3.
3.
We don't change. It's here, right? And
19.
And hold on. Array at 5. 0, 1, 2, 3, 4, 5 is 14.
Yep.
Yeah. So max this one is 0, 1, 2, 3, 19, right? 19 plus 14, which is
33.
That is exactly right. Beautiful, beautiful, beautiful. Okay, so let's compare. Now we think 28, which is the previous one, smaller than 33. So we choose our maximum at index 5 equals 33. Then we got our this goal. So whatever max the array. What do you want to call the reduced subsums array? Yeah, who write that one? Yeah, I don't know, like, yeah, I don't know who write that steps. Don't delete. Okay, okay. So that will be that one, right?
7, yeah, 7, 10, 19, 28, 33.
Yes. Okay, so, Habana, where is your pseudocode?
I didn't write actually. You were writing, so I thought it doesn't look good.
Okay, that's fine. Okay, so so Ray, do you want to explain to Sunny so I can write the pseudocode? So I don't, can you, according to our walkthrough, make it like a pseudocode?
Sure.
Uh-huh. So Sunny, do you have any questions?
No, the thing is that I couldn't, like, what is going on, I couldn't understand anything.
So the problem statement, can you scroll up, Jennifer? Can I read the problem statement?
Okay, hold on a second. I try to put that one. Hold on a second. Okay, I'll put that one here. And, yeah. Okay, problem statement here. Yeah.
So the problem,
Yeah.
so the problem statement is write a function that takes in an array of positive integers and returns the maximum sum of non-adjacent elements in the array. So we have been given an array of, I know, like 7, 10, 12, 7, 9, and 14, and we have to, as we loop through the array, we have to return the maximums of non-adjacent sum of non-adjacent numbers. So 7 and 12, 10 and 7, 12 and 9, 7 and 14. These are non-adjacent. You agree with that, Funny?
Yeah.
So basically, we manually went through the process of how you would do it manually, and if you can bring up that.
Maybe just show him the dynamic approach, because manually, just to illustrate what does the problem mean.
So that.
So
when you said-
basically, to explain that formula.
Yeah, so we came up with this formula where, at any, so the maximum sum at any given point, and when you're in the loop, it would be the maximum value of the sum prior to that current element. In comparison to the one, how do I explain this thing? Max value of max sum I minus 1.
I minus
minus 2,
I would say
and array
the current element, the previous value from the current element.
I could do a quick walkthrough if this helps at all.
Yeah.
Real
Yeah,
quick.
sure.
If you can, yeah, that would help, Devin.
Devin, can you do a quick walkthrough? Then you can tell us the pseudocode steps.
The pseudocode or the real code? Either way,
Pseudocode.
what line? What line? Pick a
246.
line. All right, fine.
Okay. So we're gonna walk through, right, or pseudocode? What you gonna do now?
I gotta walk through
Pseudocode,
this.
right? Do you see it?
This is gonna be super quick. I'm basically gonna explain what we're looking for at each number. So, you see 243. Wait, that's I was thinking that was the actual array. That's the array.
That's
we want.
the result.
Right here, line 12 doesn't. Line 12 is
Yeah, I
that's-
obviously can't show both of those lines at the same time. But but anyway, so the easiest way to explain is for line 243, we're showing the greatest value of the sum at this index. So right now we're at array index 0. This is there's only one number to compare. So this is only one number to compare, so that's our biggest sum at index 0 is the first number. Index 1, we now have two numbers to compare. We're comparing what's the biggest number between 7 and 10. Okay? 10 is bigger than 7, so the greatest sum that we have possible between 7 and 10 is 10. Now 3 is, the number here is supposed to be 12. So now that we have 12, we're trying to again find the greatest sum of non-adjacent numbers. So 10, as of right now, we're only comparing these three numbers. 10 doesn't have any non-adjacent numbers, so we're just looking at the value of 10. And then we see 7 here. 7 plus what would be 12. Just 7, yeah, 10, 12, 7, 9, 14.
It's here, line 12. Why you write it again? Okay, fine.
Because I can't see it.
Okay, fine. Ignore me, please. Continue.
Okay, because I'm looking over here and I'll delete it when I'm
I'm
done.
gonna copy that one again.
I'll delete it when I'm done.
No, don't delete. Okay, continue.
I don't need that twice. Get it out of here.
No! This
Do
is
you want
over.
me to explain this?
Because we got to the conclusion. Why you put that shit above my conclusion?
Because
This is me and the Jones effort conclusion.
I'm done. Okay.
Okay.
Forget I said anything.
So you do anything below 246.
Because I would like to look at the original array and the solution on one screen instead of turning my head every 5 seconds, but whatever.
Yeah,
We
what?
could just post the solution twice. Why not? That
No.
also works.
There. Okay?
That was my point.
Yeah, do it.
Okay. So the index of 2, this is where our second index is, we're comparing the greatest sum of non-adjacent numbers. We'll only have 3 numbers to compare. Since 10 has no non-adjacent numbers, we're just comparing the sum of 10. And the sum of 10 is less than the sum of 12 plus 7. So the greatest possible sum we can have is 19. So now we move on to index 3, which is 7. We already know that the greatest sum that possible that we have is 12 plus 7. So that's what we're comparing here. So we're comparing the previous index, now that we have more numbers. We're comparing our previous index, which is 19, which is the largest sum we have so far of non-adjacent numbers. And we're comparing that to the sum of 7 plus its non-adjacent number, which is 10. Now we compare the two. 10 plus 7 is 17, and our previous largest sum is 19. Because 17 is less than 19, after comparing 4 numbers, our largest non-adjacent sum is still 19 through 4 numbers. Okay. So now we're at index 4, 0, 1, 2, 3, 4. We're at index 4, which is 9. So between index 9, we're comparing our previous largest adjacent number, which is 19, with the sum of 9 plus its non-adjacent number, which is 12. right here, because it is 12 plus 9 is greater than its largest, the largest non-adjacent number to date. We are now oh wait, I'm sorry, I messed it up. So we're comparing 9 rather with its non-adjacent sum, which is here at 19, because we're comparing indexes. So the index of I minus 2, this is our current I, minus 2 is 19. So that means 9 is not adjacent to this total sum that we have here, which is 7 plus 12. We don't need to keep the track of the original values, 7 plus 12. We just need to keep track of the total largest sum up to this point. So 2 indices ago, the largest sum was 19. 9 plus 19 is greater than 19 by itself. So we now have a new largest sum through 5 numbers. And that largest sum is 28. So now we're at our final number in the array, index of 6, which is 14. So now we are comparing our previous largest sum, which is 28, we're comparing that to the value of I minus 2. So our current previous sum to the value of our current index plus the largest sum 2 indices ago, or 2 numbers ago. So 14 plus 19 is equal to 33. 33. The sum of our previous sum plus 9 is less than the sum of our previous sum plus 14. So 28, the value of 28 gets replaced by 33. So we just keep comparing.
Nothing.
Huh?
So, yeah, you were saying something and then.
I say great job.
So we're just comparing our largest sum that we keep adding to. We keep adding to our largest sum of non-adjacent numbers, and we just keep comparing each number to our previous largest non-adjacent sum to keep track of both what is the larger sum and also which numbers are not adjacent to each other.
Mm-hmm. Do you like the formula? Do you like the formula, Devin?
I mean, the formula is the answer. It's not pseudocode, so yes.
Okay. Okay, Sunny, do you understand?
Yes, it is clear. Thank you, Devin.
Mm-hmm. Okay, Devin, can you tell the pseudocode and I type?
I have no idea what pseudocode you've already written like the entire equation in pseudocode, so I don't know what pseudocode you want me to add. Like, I thought we should have been coding like 30 minutes ago.
Okay, let's code then. Let's code. Okay, let's code.
You've already got half the formulas in the notes, so I'm like, I don't know what pseudocode to add.
Okay, so let's do it. So what is the first step? So we are coding now, John.
Awesome.
Mm-hmm.
So first step is we are looping over the array, right? For I,
Okay,
format
so
I.
Devin, you navigate what? Okay, so.
Wait, Devin is Devin is stepped away. Hold on.
Okay.
I'm not stepping away. I'm just. It's dark now.
I can still chat with you, John. So
I have to
first
turn the light on.
we need to get the edge case, which is first two elements. So we don't need to do all those complicated stuff. We just choose the bigger one, you know. It's
So
just
remember-
the links stuff.
Remember,
it is
dynamic
zero, I mean, in the
programming
problem
replaces
didn't
recursion. So as recursion, if this was a recursive problem, the first thing we need to account for is our base case. So dynamic programming is a way to basically solve a problem recursively without the overhead. So we would formulate our problem in a similar way, which is we need to account for our base cases first, or our edge cases in dynamic programming.
Okay. Okay. So we need the first step. We need to define base case, right?
Essentially.
Okay. So what will be the base case? Which node do you want to lock, Devin?
This is fine.
Okay.
Yeah,
Okay.
it's more of an edge case in dynamic sense. Well, it's the same. It's fine. We'll leave it. It's base case.
Okay, I can see this, you know. Okay.
Are we checking for if there are any elements and then return 0? Is that the first thing you do?
That would be the first. Yes, we check if basically if the array is empty.
Yeah.
Or if the length is 0, right?
Yeah,
Yes.
so it's
That's
the
the same
line.
thing.
Same,
Right.
yeah.
Empty and
Yeah.
the same
Empty and 0
length.
or-
Yeah.
yeah.
So if what? Array dot length?
I'll just
Equals
check
0.
not array dot length.
Not, oh yeah, exactly.
It's just in case someone throws a null in there or something. Same
Return
difference. Return
0.
0, right?
because there's no sum.
So if that means if the length is empty, array return 0, right? That means.
Correct.
Okay.
Or if the
And
array is
so-
a number, or not. No, I was never mind. But yeah. So the next base case we check is if basically our array only has one item.
Okay. If one is empty array. Which case 2 is only one element, right?
Yeah. Yeah. Some of these notes are self-explanatory.
Return array at I?
0. There is no I.
0.
Oh, because only one element. Okay.
Here, don't we declare an array with like a new array with the array length which is passed as argument to? I'm talking about the maxsums.
No.
Basically, no.
Because we are doing in place, right?
Yeah. Yes. So, in the solution.
Because we are manipulating the array, so we need to preserve the while manipulating we need to preserve the existing array. So the
So,
value.
yeah. Here's the thing: we don't necessarily have to preserve the original array. So, if for those who have the algo bus and the algo expert, we do make we're about to. That's the next step. We're gonna copy the array using array.slice, but Jen, spoiler, we're gonna create.
Copy the array using array dot slice.
Okay, people can read the code. You don't. Here's another lesson. Don't if your notes just basically if your notes in the code read the exact same thing, don't write the note. It's redundant.
Maybe begin beginner newbie don't know array dot slice means to copy array. Beginner newbie, you know.
Beginner newbies don't get hired. Move on. So if you don't know if you don't know how to look that up, you're not getting hired. I'm sorry. Because there's much more involved than making a copy. So anyway, we're gonna create a.
So what is step one? Huh?
Yes, because we're not redefining the array, we're mutating the array. We can
Okay.
mutate the array and keep it const. Too many notes.
I don't have good memory.
No, I agree with Jennifer. I think these
Yeah. So right, like all those steps, like 33, 28, 21. How can you remember if we record, we forgot?
Devin, in that matter, I like what Jennifer does. I like the old school.
Well,
Yeah.
first of all, write my code, because then my brain gets put on pause, and I was gonna
That's
explain it
like
anyway, and I gotta pause my explanation because you're on. And I could have explained all of this. You would have had a more concise note, but then when you stop to write the note before you write the code,
Why you run out of stack space?
Yeah, Stack Overflow, because she's doing the recursive, and I'm just on pause, like. So const whatever, I don't know what we called it you called it max sums or
Max sum.
sums, yes. Because I have more to explain. Equals array.slice. Now
Can I ask a question?
it'll probably be answered by my explanation, so ask it.
So why maxsums is array dot slice?
You really want to know why?
Yeah.
Honestly, there's no reason why. So if you're unaware with slice,
Then who knows how to write this code? Like how the code come out?
can I explain?
Yes, please.
But before you explain, Devin, where is the for loop? Aren't we looping over the array?
Yes, we need to have an array to loop over for. You see what I mean? Y'all be jumping ahead, and I can't even explain.
You take that array then loop it. Okay, so my question is why we just directly loop through this array? Why we need to make a copy?
You don't need to do
That
anything.
is my question. Why we just don't for loop the given input array? Why we need to get a slice?
Because he's going to use it to store previous and previous values into it, and then keep track of it and add them together. Take the max of them.
Okay, so if we want to manipulate it, so we need the array dot slice, right?
Yeah, he's gonna, just like he did on that right side where he put the other array, it's keeping track dynamically of the maximum sum at a given index.
Okay, so basically we want to get this called the rebuild array. So how we rebuild, we don't create
It's just another array that's keeping track of the maximum values at a given index.
Okay,
That's it.
so basically we just manipulate the given input array.
You're not manipulating the given input array. You're using the input array as values to determine the maximum value in this new array, that second array, and recording it. So at index 1, your maximum value is the only element, 7. At index 2, okay, what's greater, 7 or 10? 10. So that's your new max value. So this output, just consider this your output, your results array at line 249. So your results array, right? At any given index, and from the given input from 247, you're recording the maximum value, and that's it. It's just a separate array that's recording your output, and that's all it is.
But we don't do we don't do empty array, then we push. We don't do that.
You could do that.
No.
That could have been an
But
option.
that is not optimized. Okay, understand. We create extra space.
Yes.
So if we don't want extra space, we do array dot slice. Got it.
Well, you are
Why do
creating
I
extra
even?
space.
Why do I even
So
try to explain? I don't even know why I try to.
That is extra space. It's just initializing another array. That's all right now. Don't worry about it.
You're trying to explain, but Ray talk faster, so you can explain one more time. We can take advice from different perspectives.
Just let them code, and you'll see. It'll come together.
Yeah, it will come together.
So
Move on, Devin.
It's man. I had a whole. Never mind. So we're just gonna write the loop. If you want to know more about array.slice, the MDN link is in the chat. Y'all can.
Can I take a look?
And then y'all can ask more questions. Okay.
Everybody, can I take a look for that one?
Sure.
Okay.
This is less of a lesson and more of like a study group. So I'm gonna let y'all read that. Do you understand? You kind of missed the description, but do you understand how it works?
No, can you please explain? I only see some animals.
No, because you didn't let me explain, but I tried to explain.
Okay, can you please explain that?
Oh my
It's
goodness.
not
Okay.
animal, it's like a food.
Okay.
The first line itself tells like what we are doing in our code.
So yeah, it's sorry, I was like and so here's can I share can I even share my screen?
Yeah, you can share your screen. I stopped sharing, you can share. Can you share your screen, Devin?
Let's see
Mm-hmm.
if I this is gonna get complicated, so let me, because I'm sharing and recording, so let me hold on.
Yeah, we can hold down. No problem.
My entire screen.
Okay, I'm gonna copy that one in the notes.
Okay, I hope you guys can see my screen. Ignore that it's dark, it's just ignore it. So I'm gonna have const new animals equals array dot animals dot slice, and then new animals dot pop. Just new animals dot pop. We're gonna console dot log animals dot log animals, and we're going to where did I put that at? Oh, whoops. I missed something?
Devin, you want to make it easier? Just use the spread operator and copy. And I think everyone knows what a spread operator does. Better than slice.
Yeah. Oh, I forgot that. Yeah, I was trying to make a point, but
Yeah, just give Devin a little bit time.
sorry. So this is more or less. Oh, I can't just. It's not VS Code. I gotta.
Can you put the example with our problem element?
No, I can I explain first before I start copying and pasting stuff right now?
Yeah.
I really need to. Thank you. So, so right now, if we're reading it, slice method returns a shallow copy of a portion of an array into a new array object selected from start to end, and basically, and the key part is the original array will not be modified. So slice creates a copy of the original array, a shallow copy, meaning that it references the original array. Okay, so because it references the original array, our array.slice variable, in this case in new animals, all it does is point to the original. But as we make mutations to our sliced array, then it will save those changes but keep the original references. So like newAnimals.pop removes the last element of an array, which is why when you run it, new animals has one less value. It's mutated. All these values are still referenced to the original array, but any mutations we make are only made on our new animals declaration. So basically, array.slice is a way for us to reference the original values of the array and only add space when we actually absolutely need to, which is when we start going through our loop and changing the values, updating the values from that value at that index to our new largest sum.
Okay, and without to create extra space.
It will create more extra space as we overwrite those values, but only as we update them. Any values we don't update will basically still point to the original array. It's ever so slightly more efficient than just using the spread operator, but the difference could be spread is probably going to be easier to read and easier to remember for 9 out of 10 people. I'm going to stop sharing now. Stop presenting. But that is, in this case, why we would use something like array.slice. Because it creates that reference, and then ideally it would not create any extra space because it doesn't create an entirely new copy of the array. But you don't need to really know all of that right now. But that's why we use slice in this case. Yes, you could just use the spread operator. Technically, Mike could, if you do it right, just mutate the original array and not worry about it. But extra comment there. But that's what we would. That's why we would use something like this.
Okay, thanks for the explanation. And we appreciate. Okay, so we're gonna continue. Yeah, I'm gonna continue. Okay, so let's continue.
Yeah. So maxsum is just a copy of the array that we can mutate. That's all you really need to know for now.
Okay. Okay. What is step 2? Wow. Try. It's 7 p.m. Try think we start at 7 p.m. Okay, but still welcome to join. Okay, what is the step 2, Devon?
Okay.
Loop.
So, remember my earlier explanation, each index in our maxsum array is going to keep track of the max sum up to that given index. So the max sums is a copy of our array. Our max sum index 0 is going to be our first number. Our max sum of 1 is going to be the greatest, the bigger number out of index 0 and index 1. So we want to assign the value of max sums index 1 to...
Can I interrupt?
Go ahead. You just did. So go ahead.
So when you have two elements, the adjacent rule doesn't apply, is it?
When you have two elements, the what rule doesn't apply?
The pink cursor, can you move, please?
The you know how the question in the
Pink cursor, move.
original question, it says you have to select adjacent numbers, right?
No,
Adjacent
you don't.
number. Non-adjacent.
Non-adjacent. Sorry, non-adjacent.
Right.
So when you have two numbers, I guess that rule doesn't apply.
Of course, it
I
applies.
mean, it still applies. It's just that
Yeah.
they're both numbers are adjacent, so you have to just pick one or the other. You can't add them. That's the only difference. It's not really a sum at that point.
Yeah, that's what I asked. I asked Kalpan in the beginning, right? If you only had two elements, 1 and 1.2, what's your max sum?
1.2.
Yeah, because you can only take one. They can't be next to each other.
Yeah.
You just take the biggest number of the two elements. That's it.
What's the biggest 1 plus 0? Like that's what you're basically summing because they don't have adjacents. So 1 plus 0 is bigger than 1.2 plus 0? No, it's not. You take 1.2.
We have three edge cases, Joe, here. So the first one is if array is empty. The second one is if array has length only 1, and if the third one is array has length 2. There we pick the max, the element which is like a bigger number.
Okay, got it.
Then
That
we
is
start
true.
looping.
That is
really only two
technically
edge cases.
true, but that third edge case is solved within when we start our loop. It's kind of
Yeah.
taken care of, basically. It's still an edge case, but yeah.
A real edge case is if you take into account negative numbers, which I don't think we're going to do.
I
No.
know we don't do because it's say the positive integer.
Yeah,
the
exactly.
rate.
Right.
Okay, no need to
okay.
get upset, Jen. We're just
Well, that's because pay attention.
But my point is there's only two edge cases, 0 and
Yes.
1. Only
Yes.
two.
Right.
he's not changing the problem. We're just
Devin, do you still
Sorry
remember?
for the digression, Devin. Move on.
Devin, do you still remember where you are? You say like something 1 or
we're
whatever.
comparing. Like I was saying, our max sums array is going to store the max sum of non-adjacent numbers up to that point in the index of the array. The max sum of index 0 is just going to be the first number in the array. The max sum of index 1 is going to be the greatest of those two numbers, index 0 or index 1. So we are going to assign max sums index 1. We're going to assign that value to be equal to the greater of the two values. The greater of whatever's bigger, array 0 or array 1, that's going to be the value of max sums index 1.
So it will be the greater value of the max sums array, right?
The greater value of the first two numbers in the
First
array.
two are numbers in the array.
Okay, so we're gonna put assignment max sums. So it's this one, right? Not the array anymore, because we're
No.
gonna mutating the
We're going to compare values in our array, and our max sums array is just going to keep track of our largest sum up to that point in our loop.
Okay. Okay, so we're gonna assign max sum 1 to be largest, right? Then how can we assign to be largest?
the shortest typing way to do that would just be math.max between array 0 and array 1.
Math.max.
Yes. Array 0, comma,
First
array 1.
element, array 1, like this.
Correct.
Okay.
Okay.
Mm-hmm.
So now that we know our largest value between, our first two numbers, now if it's greater, whether or not it's greater than that, we're going to now start our loop.
Okay, now we're gonna loop.
As long as we have at least two numbers, we start our loop.
Okay.
Jennifer, did you miss a step? Max sums 0 equals array 0?
Huh?
No, because we have a shallow copy of the array, so max sum 0 is already array 0 because we copied all those values. And we're just changing those values as we go along.
Got it.
Okay.
So right now the only difference in values between max sums and array is the math.max that we've reassigned, which hypothetically anyway. So now we would start our loop.
Okay. Loop a for loop.
For loop. And here's where you see that non-edge case. So we start I. I didn't know if you were waiting on me or not. So
Yeah, I'm waiting for you.
So we're gonna start our loop at index 2 because we already know the max sum of index 0 and we already know the max sum at index 1. So we're starting our loop at index 2.
Yeah,
So I is equal to
everybody.
2.
Line 162. When we do is start at I at index 2. Remember, Joe?
Yeah.
When we do that stuff. Okay. Then we're gonna.
So while I is less than array dot length I plus plus.
Okay.
And you see, this is why we don't. So basically, like Ray mentioned, if our array has only two elements, this loop will not run because I is not less than array dot length. If our array only has two elements and I starts at 2, I is not less than 2, we don't run our loop. We would skip it. So.
Yeah.
Is there a reason you're not doing length minus 1?
Wait, it is array dot length minus 1. Sorry about that. But.
Array. I.
Wait, yeah.
No, why
Wait,
minus
isn't it?
4?
Wait, you already. No, it's just array dot length. It's tripping. It's less than. So if our array length is, what is it? Our array length is 6. So as soon as I is no longer less than 6, our loop should end.
Okay.
Okay. So continue. So now we are iterate the. Can I ask a question? Can you see the notes line 247 and the 249? Are we loop through the 247 array or 249 array?
247.
249 we haven't created, so.
Okay. Okay, got it. So
Yeah.
our I equal to our first element is 12, right?
12.
Correct.
I mean, the
Okay.
length of both are going to stay the same, so it technically doesn't matter, but I would rather loop over the original array if I had a
Here,
choice.
you just applied the formula, right, Jennifer? Whatever you
Yes.
have.
Oh, yes. Okay. Continue, Navigator Devil.
Well, you already got the formula, just copy paste it.
Copy paste.
I'm not with the long explanations of stuff.
Oh, yeah,
already
you
done.
say it. Copy what?
This is the problem with you having pseudocode that's basically code. I'm not going to want to repeat it.
You just repeat.
I don't like repeating myself. I'm a programmer. I teach the way I code. It's very dry.
Okay, so what are we gonna do after we loop?
Okay, fine. So we're going to do the same thing. Our max sum of I is going to be equal to the formula which you refuse to copy paste.
So that will be max sum
I.
at
Max
I.
sum of I, yeah, is equal to. Well,
So that will be this,
Max
right?
is I minus 1. Yeah.
Okay. Max value.
that's not a thing.
Max value. Okay, I need to find the formula. Hold on.
It's
a
just
second.
math.max again.
Yeah, it's math.max.
Okay.
So just math.max. So
Then the formula
sum.
is max sum.
index I minus 1,
Mm-hmm.
comma,
And
maximums I minus 2.
plus array at I, right?
Yes.
Can you explain that formula?
Didn't we just spend an hour explaining this formula?
Just explain one more time here. Don't need to use number.
Don't need to use. That's the point. Okay. So we are comparing our current index of the array with we're comparing our current largest sum of non-adjacent numbers, which is supposed to be max sums I minus 1. That's supposed to be our current largest sum of non-adjacent numbers. We're comparing that with the set of non-adjacent numbers of our current index, which is array I, our current index in the array, and our previous sum of largest non-adjacent numbers. And we are trying to see which sum of non-adjacent numbers is greater. And when we determine which one is greater, we want to store that as our new largest max sum.
Wow, that is intelligent. Only one line is like include all those steps. Intelligent. Okay, got it. Okay, what's next?
We exit the loop and return the last value in our maximums array.
Return max sum.
Yes. The last number in the
Max
maximums array.
sum I. Oh, the last element, right? Because the last element is the.
Yes.
Okay, how come it could not be the middle one? Need to be the last element.
Because
Oh, yes, because we always take the greatest one to be the next current one. So the next current one on the right will always be larger than the one on the left, right?
So yes, so if we never had a larger sum, then our max sums array the last value in our array would be equal to. It'll always have our last value. So,
okay, so that,
yeah, if we never find a larger, adjacent sum, then it'll just keep saving the same number up until we finish our array. It'll keep saving the same sum. Because it's cumulative, it in place keeps track of our largest max sum of non-adjacent numbers to date.
okay, I fully understand. Does anybody don't understand? Thanks, Devon, explanation.
Can you remind me what non-adjacent numbers mean?
Non-adjacent number means, for example, you see the props, okay? So this is line 12. Can you see the line 12 on the slide? So non-adjacent means, so if 7, the next number is 10, then 7 and 10 is adjacent number. Adjacent means next to each other, like the next door neighbor. So the 7 non-adjacent number will be 12.
Gotcha.
So as long as it's not next to that number, then, so for example, like 10, the adjacent number will be 12. The 10 non-adjacent number will be 7.
And 9 and 14.
Then the 9 and the 14 will be the 10th non-adjacent number. Try it. Okay, I think he understands. So your neighbor will be your adjacent number. As long as not your neighbor, it's non-adjacent number. Okay, so we're done. Let's do the big O notation.
Or you could run it.
Yeah, you want
Oh
to.
yeah, wrong it. Forgot that important part. Wrong it. Okay.
You forgot one parenthesis.
Oh, hold on a second. Go expert. And diet. Oh my god. Yeah, all passed. Looks good. Okay. So we're gonna do the big O notations. Devon, you wanna continue, or Ray, you wanna do it? Ray, you wanna do big O notation?
No, I think you should ask someone that hasn't done it before.
Okay, so, okay, who wanna do that big O explanation? Bonnie, you wanna do it?
I can do that if you want. So
Yeah.
I think time complexity would be big of n.
Okay, hold on, I need to, N, okay, you wanna explain?
Because you are just using that iterating to that one for loop. That is the reason why it will be big O of n.
So only iterate every element in the array, right?
Yes.
And when we do the array dot slice, we did not create extra like empty array to store, so it's don't.
So ask someone else what the space complexity would be.
Oh yeah. So Ray, you have anything to add for the time complexity? That's it, because we only have one for loop, right?
Yeah, I mean, I'm not going to go into the micro details, but like, Bonnie just,
like a bit.
yeah, it just yeah, as Jennifer explained explicitly, you're iterating through every element. So the for loop doesn't mean anything. A for loop could be anything, but specifically this for loop is iterating through every element to be more precise.
Yes. Okay, so space complexity, Fanny, you want to continue?
Ask someone else.
Someone, Ray, you pick one because you are the director.
All right, I'm going to pick out Yayu.
Yeah. Yes.
All right, I think the space complexity should be O of n.
Why?
Because you just create another array, shallow copy that, right?
Mm-hmm.
You create a max sum array, so you need extra space for that. So
Right.
it could be O of n.
Yeah, why ON specifically?
I have no idea.
Okay. It has to do. It just look at your logic. What are you storing in that output? In that
Output
max
of,
sum
It's
array?
all there. You just need to say it. You had it all there.
I just
It's only a few lines of code.
I just create a new array to store the maximum sum for every element.
The maximum sum for every element of what?
That's the original array, right?
N is our original array, correct? So,
Yeah.
N is our original array. So how much space does the new array create?
Just the n. The same
amount.
as the original array.
Yeah, because you're tracking as you're iterating in your for loop. At the same time, you're inserting into that output array an actual value.
What is the answer?
He said it.
She's right. We were just making sure she knew she was right.
Yeah.
O1.
O of n. No, it's O of n. And I only stress this so that you can explain this to your interviewer exactly why is it O of n. You can't just say it's a for loop. You can't just say it's an array. O of n. You have to explain why is it O of n.
O1 or ON?
It's O n. She said O of
So
n.
N. This solution is N. We can make it O1.
I see the answer is O1.
No, it's O of n.
We're telling you it's ON.
Okay.
So the reason of O of n array is because it's creating another array with exactly the same number of elements. That's
It's exactly the same number of elements because you're tracking, you're updating in the code. You're doing a for loop. Hey, at element 0, what's my maximum sum? Okay, I update my output array with the current maximum sum at this index. At index 3, I'm adding in another value at that point in time. At index 5, the last index, whatever it is, it's exactly one-to-one mapping from your input array to your output, and your input is n elements. Therefore, your output is n elements in your array.
Okay. Got it.
I think why Jennifer is saying the space complexity should be O of 1 is, I think without even doing the shallow copy, I think so we can directly modify the array which is given. I think so.
Well,
Yeah, I think we did
It'd be
not
difficult.
we did not create another array. We only muted.
yes, you did
No.
create another array. You called it
We
max
created a new
max
array.
sum. Max.
We created an array, but I'm saying that without creating a new array also we can do that.
Yes, you
If
can do that,
If you're doing
but-
like that,
but-
it will be big of 1.
But yeah, it's easy to say something, code it now to make it constant space.
Yeah,
That's the
Fani, go
difference.
ahead.
Yeah, I did the O1 solution. I was like, this is hard to read. And I wrote it.
No, I'm not
So I
saying
was
that
like-
your people are wrong. I mean, I'm saying the reason why she's saying big of 1. Like, I'm saying the only reason why she's saying that, I'm saying that is the reason. I'm not saying
right.
that
Yeah.
it is.
No, Devin, you said you had the O of 1 logic
Okay.
written down.
You could alter this solution essentially to make O of 1. I found it hard to read and I didn't like it. So at least the way I wrote it and
Okay.
the way they named the variables. So I used the array instead just because I thought it'd be easier to see how it's working.
Yeah, I have 2 other solutions. A recursive one.
Devin, how did you modify to O1?
well, we only really need to keep track of their previous value, our current value in the array, and all we need to keep track of is our previous max sum, our current max sum, and our index. So, okay.
You're really only keeping track of the previous two values.
Two values,
Yeah.
yeah. So you need two variables. That's it.
So yeah, you would just create variables names. Hopefully you don't get them confused like I was doing in the beginning. I'm like,
So
I'm just
if
using
we
array.
do two variables, it will become O1, right?
Yeah, so you would have like, I don't know. You would
Previous
have
minus
something-
one, previous one and previous one, previous two.
Yeah, it'd be like previous one, previous. Yeah, the naming gets. there's
Previous
no
to
good way
previous.
To name those.
Actually, my
for
code
our
exactly uses those variables.
So
If you
our
want me to show you
current
my code, I'll show it to you.
O1.
I did it
Yes.
just
Yeah.
Please give me 1 second. So for our current solution is OON, right?
Yes.
Yes.
Okay.
Yeah, I was like, the solution had it named as first and second. I'm like, I don't know what that means. It's like previous one and previous two. I'm like, that's also
Okay.
stupid. I'm like, I don't want to have to
I-
explain this and keep track of it.
So pretty good. We gonna thanks for the explanation, Dev. And so we're gonna get the solution 2 from Ray, right?
Sure. How do I share my screen?
Okay. Can I ask a question? Is your solution
Probably just
same
copy-paste it.
or different? Big O. Big O is same or
Same.
different?
Big time complexity is the same. Space complexity will be constant time.
Okay, so I gonna stop sharing. You sharing, then I copy your code.
I was gonna
in
say,
the-
can't you just copy paste it in the thing?
Yeah, but
yeah,
I'm gonna
just copy paste.
Yeah. Cause
Either
he
way.
wants Python tutor.
Yeah.
We should all be using Python Tutor, to be perfectly honest. Like,
Okay, so
it's a public
Ray,
thing. It's,
you can do Python tutor now. I stopped sharing already.
Yeah. Present now.
Can you make it full screen?
Yeah. Can you see my screen?
Can you make bigger?
All right. I did it a couple different ways, so.
yeah, the formula is basically the same.
Yeah, so, I only did the one edge case. I didn't even bother the second. So if your empty array just return 0, I created two variables, the previous one, because we only care about the two previous values, right? So previous one is the index before, or the element before the current one. Previous two is two elements before. So then I did a for loop for let from the current of the array, your input array. I set a temp is equal to the previous value, and then the previous one is equal to the max between the previous one and the current one plus the previous two, right? Because it can't be adjacent to one another.
The previous two are two numbers or one number?
Previous two is one number.
Okay.
It's the two
It's
elements
around
before the current index,
of
right?
the-
So
it's
here, if I'm
around
on
of
120,
element 2, yeah.
if I'm on this, that means previous one is this, and previous two is this, and this is
Okay,
current.
got it.
Yeah. And then I just reassign previous two to what was previous one, but I didn't, I had to be careful because I was overwriting it, so I put it in a temporary variable first. So, and that's pretty much it. And I return it, I step through it, and I just keep adding them. So I just took this, 75, whatever, this test case, and I just called it. So,
How can you assign them at 0 initially,
Uh,
like a line 5 and the 6. How can you assign them become 0 to start with?
What do you mean? I start at 0.
They
So-
initialize at
Because
0.
we start at index 0, because
Yeah.
the for of loops over the whole thing.
So that is the index number, right? Not
So-
the value.
No, that's the value.
I can't even think of what I was explaining of. Because I don't know what you're asking. But
What do you mean? The 0, you start off, you always start off with the 0th value, the first element. I have to start from beginning to end, right? My for loop. This is what my for loop. I'm going through the array. This is my array. So each element I represent as current. That's just the name, right? This is current, the first iteration. When I step through this, I'll be the first. So here's my array. My previous I initialized to 0. Now the current will be 75. There it is. Right? There's 75. 75.
So your
That's
previous one is element, not index, right? Your previous
one is 0 right now. Is not any previous one and previous 2 are both 0 right now.
Yeah, I initialized them to 0.
Oh, to start with.
Yes.
Okay.
And then we reassign the values outside of the loop. So when we start comparing, we change it.
It's like a accumulator variable, like a rounding sum or something like that, right?
Well, that's what I'm going to add through this, right? I'm going to reassign it. So the given max number at any index is being updated, right? So at 0, the max is definitely going to be 75. At 1, it'll be this, 105, because it's bigger than 75. At 120, I have to say, hey, 120. My previous max is 105. So I have to say 105, or do I take 120, the current plus previous 2? 120 plus 75 is going to be bigger, so it'll be 195 at this point. So by the third loop, this will turn to 195, right? Because I'm taking into account the previous one or 2 before that and the current one. And then this gets updated, shifted. So I shift my variables, previous 1 to this one. This will now be, previous 2. When I get to this third element or fourth element, this will be previous 2. Then this will be previous 1, right?
Mm-hmm.
And I'm keeping track of the maximum sum at every point in my loop, which is this. I'm starting from left to right.
Okay, got it now.
Yeah.
Thanks, Ray. Always come with alternative solutions.
Yeah, that's 105. I mean, that's basically what Devin was getting to, but I just have different naming conventions or maybe different little order.
Can you paste your solution in the Google Meet so we
I did.
can
It's
put
there.
in? Yeah, because you have the access now.
Yeah.
Nice.
Jennifer, can you see if this works and for all the cases?
I'll go expert, right?
Yeah.
See,
No, you
this-
didn't paste.
This solution.
Ray, you didn't paste.
I didn't?
He said it's
No.
in the Google chat.
Oh, Google
is.
Chat.
It is
Okay,
there.
hold on. Okay, I listen wrong. I thought you paste in that. Okay.
You see it here. I can see it. You can see my screen. It's right here.
Okay, I'm gonna do it now.
Like I said, when I got to the third index, 195, right? When I got to here, 195 is the new max sum. See, now it's 285 when I get to 75. Now it's 330.
Okay, so I'm gonna.
And that's it.
Okay, I'm gonna share my screen. To run it.
Okay.
Later.
I mean, I have a second solution, a recursive solution too.
Okay.
Even dynamic programming at that point?
Yeah, I mean,
Oh,
well,
Ray, your solution
well,
is not
really.
failed.
What?
Your solution. You want me show or don't show?
Did
Sure,
you want to
sure.
change the name of the function? Or?
Okay,
No, but it's not returning an array. I think he's returning a value, right?
It's supposed to return a value. It returns
Okay,
the
I
previous
got
one.
it.
That's
So-
a value. Just change the
only
name of the
one
function.
pass, only 2 pass. I did.
What?
I changed it.
Only 2 pass.
I changed it. Okay, hold on a second. One more time. Forgot changed. Okay, passed. You guys
What-
wanna
what-
see?
Yeah,
what
what
did
did
you
you change?
All this
Wow.
off-screen trickery that you're doing is like, oh, watch that. Like, what you?
I changed the look. You passed.
I know, but what did you change?
What did you change?
I changed the secretly. Okay, so what is your another solution, Ray?
Recursive. Let me. Yeah.
Okay, is the big O same or no?
The big O is the same, but the time complexity will be the same as the first one. This time complexity, the one that we just went over, is the same O of n, but the space I don't use any. I just use temporary variables, so it's constant time O of 1 space.
Okay, so you wanna show Python tutor?
Okay, sure.
I already stopped share. You share now.
Okay. Percent. Okay,
Hold on a second.
sure.
Was it Domino's? Where are you going?
That's funny. I had Domino's earlier today.
You start knocking the door like it must be delivery.
Domino. That's not a pizza. It's a puff pastry.
Don't be hating.
I was like, I know. Like, why are you hating? That sounds good right now.
Okay, let's continue.
Yeah, so this is the recursive. Okay, so whatever. Here's the edge case. If it's empty, just return the first value. Oh, it could be just 1, whatever. So here, else if your index, yeah. So I'm capturing the index. What I'm doing here in my function, I have 2 inputs, the array, and then I had to feed back the length of the array. And I did that from this. So whatever this array is, I took the length of it and passed it to the function. And I just defaulted to 0. I mean, this doesn't need to be there. Because you need a base case, right, for a recursive solution. So whenever you're finished with the evaluating every element in your array is 0, then you return that element. Else, if your index is 1, you take the maximum of those 2 values, the 0 element or the first element. Otherwise, you will call the max of recursively calling the maximum of the 2 previous ones plus the current one you're on, or the previous one, right? So
Yeah.
again, so it's the same thing. It's just calling it recursively, and yeah, I mean, I stepped through. It's going to be a lot more steps because recursive calls.
But that's the space complexity is 01, right?
Yeah, it should still be. No, let me think.
No,
Yeah.
this will be open.
The space complexity. Am I storing? I'm really not storing anything.
You say the big O is different.
Yeah, the big O. I think the big O. The time complexity is the same because I could have to go through every element. But the space complexity
Be O of n.
creating these
wouldn't it?
stacks. Yeah, I'm thinking because it's creating these stacks, right? It's calling the up until each one.
Yeah, it would still be O of n. It's a different kind of n, but
Yeah.
it's still.
It won't exceed the length of the of the input array.
Yeah.
And it's doing it in line though.
Okay.
So technically the space, I'm not using any extra space So it depends on who you ask. This is just something you clarify with the interviewer. Are you, from the perspective of actual physical memory space, it's really, I think, constant, right? I'm not storing it into any temporary array. I'm just inlining it as just the stack frames that are being used. So that's really just time complexity, really. So as far as I understand, from a space complexity, this looks like to me it's constant time because I'm not using another array. You can see it's just using this. It's not even mutating. It's just updating it. In the end, it will output what the value is.
So your time complexity is O1, right?
No, O of n. It's O of n. Yeah.
Okay.
It's slightly bigger because you see the previous one did 35 steps. This one's taking 74 steps. But it's still considered O of n. You know?
Not all n is created
Yeah.
equal, I guess.
Yeah.
Okay, can you copy the solution, like, paste in the VS Code?
Yeah. 1 second.
Okay.
Yeah, it's keeping track. See, 105, 195, 285. There, 330. Yep. So
this should also work on AlgoExpert, right?
I mean,
Yeah.
possibly. I don't know what kind of test they have.
yeah, I don't know.
Okay, paste first, then I can go the AlgoExpert.
Yeah, I don't know if they can like test dynamic programming. Like, I don't know if you can run tests on stack size, but maybe you can. I don't know.
I mean, it's not a. I don't think that test cases are like huge, so it should work.
Yeah, it should still work.
Unless they have something, a really huge data set.
That's what I'm saying. Unless like Jest or something can really actually be like, max stack size equals this.
I cannot run that because he has
Just change this to max
parameters.
subset.
Huh?
Change this to max subset sum.
Yeah.
You have 2 parameters.
That doesn't matter. We change
So
parameters
what?
all the time.
Yeah, you could add it. Yeah.
Okay. So I just change to max sums.
Yeah, the max subset.
Okay.
Subset sum.
Okay, max subset sum. Okay.
What are you spelling? I don't know.
This is for my own purposes. This is
I was like, I'm so confused. Like,
Yeah.
Okay. I forgot who we're still sharing.
So all your max sum need to be max subset sum, right?
Yes, just like it is in AlgoExpert.
Okay, I'm gonna share my screen so you
Sure.
guys can. Okay, so
you're not
here.
running tests in secret anymore? That's nice. That's nice.
So I just changed these, right?
Yeah, subset.
And max. That's it.
Yeah, I think so.
Okay, I don't know, cause you have 2 parameters. Oh no, your array all need to change.
Wait, what?
Otherwise it will not work.
Why did?
Well, you could have changed the. You could have just changed the parameter to ARR instead of.
Yeah,
Okay.
I was like, what?
you took the long way, but fine.
Okay, got it.
Work harder,
So,
not smarter.
sometimes these changes you will not run in AlgoExpert.
No, those changes would have. I'm tired. The hungrier I get, I'm like, now I might want Domino's instead of eating at home now.
Okay, so I'm gonna run it. Look,
Cool.
look, you will not run because your parameter is different.
That's
If
not it.
parameter-
That's not even an error.
that is max sub adjacent. That is the problem.
You have to call the function within the function.
So all these need to be changed to adjacent.
Yeah.
And
Really? Okay.
Yeah, well, obviously the function has to match, otherwise it doesn't know it's a test.
Yeah.
But
okay, so I think now it's working. Ooh. Next time, please change to the Algo Expert friendly one.
What are you talking
See,
about?
it's not working.
That's because you keep changing stuff from.
I did not change. What
I
did
think
I?
You changed.
it's not. Is it because signature is different? Because here you're providing 2 parameters versus 1.
Yes, it will not work. You need to do. You need to do like
What
a
is it
help.
returning? It's returning one number.
Return.
It's saying some of it's undefined. Is what it's saying. No, go to the one that failed.
Well, what case is failing? Why is it?
Your code's output 75. Why is my code's output 75?
That's what I'm trying to figure out.
Because I just did it in Python Tutor. It came out to 330.
That's what I'm saying. Did you have?
Did you copy the entire thing?
X return. Ray, did you paste it in the VS Code? This one?
I just did it in Python Tutor and REPL. I didn't bother.
I pasted in the VS Code. I paste his solution in VS Code, but did not change to max whatever adjacent function name.
I don't know how to explain it. I just know it works in Python Tutor and REPL. Because I can see you're saying my output in there is coming out as 75, and I just did it here live for you. It's coming out at 330.
Okay, go back. Math max plus array index. Scroll to the right.
Can you minimize the window to the left?
Yeah, that too.
There you go.
And then you defeated the perp.
I did zoom out or zoom in. Then
Well, that defeats the purpose of not wanting to have to scroll because I can't see anything. Interesting. So wait a minute. So array index is basically always going to equal 0 because we don't pass in a second parameter in the initial call.
Do you not? Yeah, in your initial call, you need to call the length, the code test array. I mean, yeah. You need to put in.
So you need to initialize it.
Yeah.
No, well, that just breaks it. So we can't pass in a second parameter.
Right.
I don't think. So
Yeah,
what
'cause
we
this
need
is
to
why-
do is define index somewhere else. So index should be equal to like array.length is what I'm guessing.
let index equals 0, right?
No,
That's
it should
it.
equal array.length. Or array.length or array.length minus 1.
Yeah,
is
I
what it
tried
says.
that, but when you call I think you're going to reset it, right? Because it's recursive. You're calling the thing again.
Oh,
right?
yeah,
It's going
it
to
is
reset it back to
recursive.
0. So that's the problem. That's why I had to pass it in as a parameter.
Right.
I tested that.
So
But you're recursively calling it. You have to pass it in as a parameter.
Okay, so what should I do?
So it would have to be outside the function, or
Yeah, it's going
Yeah.
to be help function. It will not work. It need to be help function outside though.
All right.
yeah, probably. I don't. We okay.
Okay. Whatever.
We're at 3
Yeah.
hours. We're not doing that. I'm sorry.
Yeah.
I'm cutting that off right now.
Okay. So we're gonna.
It's already Monday for Ray, so let's not.
Okay, so let's wrap up our call today, and thanks for joining, everybody. Did you stop recording, Devon?
I'm stopping it now. I need to stop these sooner because no one wants a 3-hour video.
Did you stop? Okay, we're gonna choose the next time question.